Mavi Sánchez-Vives, I think most people know about Mavi here, but I think it's still worth it to always go through her very impressive CV. So she has a MD and a PhD in neuroscience, which I think is a really great combination for research in this area. And she's now a ICREA research professor at the Institute of Biomedical Research August Pai Sanya, which is also associated with a hospital. Maybe she can explain this a bit more herself, and where she leads a systems neuroscience group. She has led several European projects, including the XR pain, extended reality assisted therapy for chronic pain, and recently also involved in the Meta 2 project, which are both related to virtual reality, which is the area she started working as early as 2004. And she has recently been awarded 2 European projects. One is the ERC Synergy Project, NEMSIS, on the study of brain lesions, and leads a European Innovation Council project called MetaBrain, which investigates the use of different nanotechnologies for precision brain simulation. So I am a big fan of Mavi's work. I think a lot of people talk about the potential of virtual reality and how it could transform our lives. But I think every time I listen to Mavi's work, I see how it actually already transforming people's lives, how people actually, benefit directly from her research, which always gives me new ideas and inspirations for my own research. So please, a round of applause for Mavi.
Okay, thanks very much, Sylvia. That was nice. Okay, I'm going to be talking about some clinical and well-being applications of the metaverse. And as a neuroscientist, I would like to raise the point that the applications that we use work because we can induce, as you all know, presence in virtual reality. We can also, as you have heard in previous talks, have embodiment, feel that a virtual body is your own. Also because our brain is flexible enough to accept these virtual bodies, and also because we respond to virtual environments with enough adaptability and realistic responses close to the real ones. So because of all this is that we can have applications that work in virtual reality, but also, as we discussed yesterday in the roundtable, we discussed that actually there can be these positive applications, but also we should take into account that there is this real effect in our brains. There are these realistic responses, and therefore we should take seriously the fact that there can be also negative impacts, and we have talked in previous roundtables and so on about the existence of harassment in the metaverse and how this has a real effect on people. So the same reasons, therefore, that support these positive applications, they also imply that there can be negative effects. And another point I want to raise with this slide is that I think it's important to take into account the brain that is there and how neuroscience, therefore, I think is entangled with the study of virtual reality. So for this talk, I'm going to talk about 4 different areas that we have worked on, and I think it should be relevant for a metaverse meeting like this one. So these are 4 more or less different types of applications, and some of them are more closer to the metaverse in the sense that referring to the metaverse, as Miguel just presented, there is different definitions, but I will take it as shared virtual environments, but also some of them are individual virtual environments, like the first ones, clinical applications in pain and rehabilitation, but they could be part of the metaverse because these kind of applications could be part of a virtual hospital, for example, where there would be different settings, as some of our colleagues have presented, where there are different areas in a hospital, they could be connected. And so this is a bit the idea about calling metaverse, these kind of applications. And some others are clearly shared virtual environments. So the first one, I would like to mention some work we have done on clinical applications, in particular in pain and rehabilitation. These are some of the earliest areas in medicine where virtual reality has been used, and I think it's the use of virtual reality in rehabilitation has been quite broad. And in particular, we were interested in pain, and actually these were some recordings from nociceptor fibers, pain fibers, that I did many years ago. So these are fibers that encode pain. However, when these signals reach our brain, they are not just decoded as sound can be decoded, or is just the processing and the decoding of these action potentials encoding pain, but actually these signals go to many different areas, to cognitive areas, to emotional areas, to somatosensory areas as well, and this makes generates a pain sensation that actually is a complex signal, and therefore the problem of chronic pain is complex because it has cognitive aspects that are listed here, like pain-related fear, catastrophizing, lack of perceived control, and rumination that was mentioned today, emotional effects like anxiety or depression, organic effects, and also pain-related illusions like placebo effects or phantom pain, which most of you know about. So therefore, pain, because pain is a complex signal, therefore this chronic pain has this complexity that can affect very deeply the people that suffer them. One of the conditions that actually Justina Swidrak in my lab has studied trying to improve it with virtual reality is fibromyalgia, which actually is a very complex chronic pain condition where there are many of these aspects together, like fatigue, brain fog, so therefore cognitive impact, depression, chronic widespread pain. It's a very complex, typical chronic pain. Very difficult to actually treat and to be successful. Justina has tried different strategies. Actually, we have found, and this is some finding that we have consistently found, that even with quite intense chronic pain, people can have full embodiment. So it's not a barrier. We thought at the beginning that maybe if there was pain, it was not possible to have a virtual body, and therefore virtual bodies couldn't be used for treating pain, but indeed, unless the pain is very extreme, there is possible virtual embodiment. However, I cannot say that fibromyalgia is a perfect target to be reduced with virtual strategies, or we haven't found them yet, but there are some aspects that can be tried. However, the problem of chronic pain is very important because there is a high prevalence. So basically 20% of adults have chronic pain at some point, and this has many different implications, what I won't list now, going from the personal suffering, of course, but also to the cost, to the impact in the economy, and so on. So it's an important problem. And what can VR offer for pain? So there is one strategy which is to reduce attention to pain. There are some classic works that probably you have heard about from Hunter Hoffman and others, where one can be in an environment. In this case, it was studied with children that had part of their body burned, and then they played a game in a cold environment, and basically reducing attention to their own body, to their own reality, decreases pain. And this is something that works quite well. Basically, people that have chronic pain, if they wear a head-mounted display and they do basically anything, they have a reduction in the pain. This is something we keep finding in different studies. So VR, just because it takes us away from this world and it takes us away from our own body, it has already some analgesic effect. But then we can do other things. So we have seen this in different studies and others also. So this is really one aspect of it. Another one is that VR can be used to decrease the pain-associated anxiety. So having chronic pain has this emotional impact on the anxiety, and it has been used for meditation and for relaxation, being in very nice places, very calm with music and so on. And this can decrease anxiety and decrease the associated pain. And we have also done this, and actually this is part, what you are seeing is a session of relaxation and then Tai Chi, in an environment where I will show you later, we use this multimodal approach to the chronic pain. So Beñat Amestoy in the lab has been interested in the mental health effects of this multimodal virtual rehabilitation. So there is also another strategy we can use, which is take advantage of having a virtual body. So I won't go now again, it has been mention the rubber arm illusion or the virtual arm illusion, where we can feel a virtual body as our own because it moves with us and so on. There is these correlations which are visuomotor and visotactile and so on, and therefore we can feel a virtual body as our own. And this, that Benhar Spanglang showed this video before, we can have this illusion that the virtual body is ours. But what I want to highlight here is, can we use this body to reduce or to modulate the perception of pain? And we did this some years ago. We did it in healthy people. We measured their pain threshold, and we saw that actually having a virtual arm that feels as own can have an effect on how on the pain threshold, on the stimulus that is perceived as pain. So therefore, having a virtual body per se and looking at it was already a strategy to have an analgesic effect to increase, therefore, the pain threshold. We saw that this effect was larger if there was a co-location of the real body with the virtual body, and however, this effect decreased if there was a separation between the virtual body and the real body. So therefore, having a virtual body per se already has an analgesic effect if we are looking at it, and this is an effect that actually Patrick Haggard, who's here, described previously for a real body. So we wanted to see whether this was the case also with the virtual body, and we saw that this was the case. We saw then that if we modulate, we vary the color of the virtual body, we could also modulate pain such that having a red virtual body would decrease the threshold for pain because it's associated probably to inflammation and so on, and therefore it has an effect. And this is very interesting because we always want to do in virtual reality strategies that we cannot do in the real world. And one of them can be, for example, changing the color of the body or doing other transformations of the body that we cannot do in the real world. This is one of the advantages of virtual reality. So we saw that, for example, I won't go now into details, but just to give you the idea that changing the color or changing the transparency levels of the virtual body, it would also modulate the pain threshold. So we found, of course, you can think, well, what happens if I have a very bad pain in my hand? What happens if my hand becomes transparent? Is it going to decrease the pain that I feel, or is it going to increase the pain that I feel? Okay, so this is interesting because imagine if you have a very bad pain and you embody a virtual body and your body becomes transparent. It would be nice if you would decrease the pain. So we found that actually this is not the case if you do not have pain. Actually, it increases. You have a worse predictability of where the pain can occur. However, as I will show you later, if there is chronic pain, actually making the body transparent can decrease pain. So this is very interesting. Just the message here that I want to transmit is that you can do this kind of manipulations in the body and see investigate whether it can modulate pain, but also you should take into account that it's not the same someone with chronic pain, that someone healthy, that we are investigating the pain threshold. So, so therefore, so far I told you that a virtual arm or a virtual body can be felt as own. It can be analgesic if it's collocated, and then we can transform it in different ways and see the effect on the pain threshold. But can we apply these findings on patients? So basically, we are interested, of course, in having good strategies to decrease pain in people. And first of all, to know whether this is possible or not. So we have done this over the years. This was a case study, but it's just one, N equal 1, but it was interesting to see that it could work. This person had a complex regional syndrome. He had very bad pain in his hand, and he couldn't open it anymore. So we reproduced this position of the hand, and then if he would concentrate, his virtual hand would slowly open. And he perceived this as a big relief of his pain. So we thought, okay, there is some strategies here that can be useful. They can be good for this difficult conditions like the regional complex syndrome. So we studied larger samples of patients with peripheral nerve injury, with regional complex syndrome, and we tried the strategies like increasing the transparency, changing the size of the arm in this case, and seeing what worked and what didn't work. So basically, we found that chronic pain, as I mentioned before, chronic pain patients can experience body ownership, they can experience agency at the same levels as the healthy individual, so this is good, they can have a virtual body, and then also we can do these transformations, and we found, first of all, that all the conditions that we tried, different transparency levels, different sizes, they would all result in a decrease of the pain. So as I told you earlier, just the fact of having a head-mounted display being in virtual reality already has an effect on decreasing the pain, but also there was some specificity depending on the condition, such that those patients with chronic regional pain syndrome, they would feel less pain if we made the arm transparent, and those with the pain nerve injury, they didn't. So there is some specificity, probably depending on the cause of the pain, we can use more successfully one strategy or the other. So we have studied other types of pain, like shoulder pain, by doing movements and so on. And therefore, I just want to go to the conclusions saying from this part, which are that we can actually find the strategies that work. Depending on the pain, it can be it can be quite effective while they are in virtual reality. Of course, there is the question of whether it's going to persist later. As if you are interested, we have some reviews on that, or you can ask me about that. But then, I have told you earlier, there are many strategies that we can use. We can have decreased attention and this. So what we did in the last study was to combine, to have a multimodal VR approach in the project XR Pain, Extended Reality Assisted Therapy for Chronic Pain Management. And what we did was we took 100 patients. This was a clinical trial. We studied 100 patients that used at home this system with personalized avatars based on embodiment with a virtual physiotherapist, and we did a combination of approaches with educations, games, exercises, relaxation. So basically we put everything together that we know it can have an effect. And this has been a study that Tony Donegan, who is here, and Benyata Mestoid have carried in the lab. Also, Sánchez-Vives has participated and will not present now because it's very recent. But basically, we can see effects which are quite promising. The pain interference score, it decreases, so people have their daily life is less disrupted. You can see how it quite consistently after the 3 weeks it decreases. But something very interesting that we found is that actually it was very positive for people to start moving more in their real life, and therefore this contributed to their general improvement that persisted months later, because actually they decreased their fear to movement, and therefore they would move more in their real life. And altogether, the virtual strategies, but also their change in movement and so on, it decreased the pain. So these are some aspects that they said, like I've been working, I mean, some people said I stopped taking opiates, which I think is quite extreme, but basically there was quite a positive feedback without going now into all the sentences that I have here. There are many uses here. Probably you cannot read it, but there are many different uses in the clinical area that have been studied, as you know, for training professionals in mental health, clinical assessment, and so on. There is one that, we used, this is already from 2012, where one can combine, of course, not only visual, but haptic interventions for rehabilitation, and so on. We now realize that even when this is very interesting, and we could do it with a very sophisticated robotic arm, and so on, however, we see now that it's interesting that people can take simple systems, head-mounted displays that they can use from home in a quite an standalone, of course, independent way. So even when these systems can be very nice, integrated with sophisticated haptics and so on, is more doable to have and this is what allowed us to do a study with 100 patients, that they can take these systems home. We had to give them the systems. There is also been, we've done a lot of orthopedic rehabilitation also. I won't go into that now, but as I said, rehabilitation has been an area where virtual reality has been used a lot, but it's been mostly neurological rehabilitation, and we have done several studies on orthopedic rehabilitation, where basically, to make a long story short, moving the virtual body has an impact on the real body. So even if the real body doesn't move, if the virtual body moves, this is going to have an impact on the rehabilitation, an impact that can be very specific, which means that if I train a certain movement with a virtual body without moving the real body, this can improve exactly that movement and not another one. So it's quite specific. So rehabilitation in general is an important area of application that could be integrated in this metaverse, this virtual hospital in the metaverse. And then an area that I am particularly interested because of my interest in my work in neuroscience is the current integration of brain-computer interfaces with artificial intelligence, machine learning algorithms for decoding the brain activity and control virtual bodies. And I think this is very impressive. It's Nature papers from 2023. There were two together where someone that had a stroke and couldn't speak anymore or move, by using these new decoding algorithms, they could actually, based on the motor signals to move the mouth and so on, and the tongue, the whole speech could be decoded and speak at 78 words per minute, applying it to this avatar of this same patient. So you can have a personalized avatar that speaks based on decoding these signals recorded with the brain-computer interface, and actually have a body that can move, and therefore you could navigate, you could be in the metaverse, interact with other people, or having some carrying out work, and so on. So therefore, there is an enormous possibility for patients that cannot interact in the real world otherwise, and I think is very relevant for the metaverse, the interaction with brain-computer interfaces. Okay, now I would like to mention something connected to the previous studies, which is closer to what we understand as the metaverse, which is the shared environment. So some of these patients that did our treatment for low back pain, we wanted to get feedback from them, and for this one does patient focus groups. Basically, you get the feedback. These people had at home their head-mounted displays, and we wanted to see how was the usability, what was their real use concerns and observations. And so we decided, given that they had these systems at home, to do the meetings, the focus groups, in a shared virtual environment. And this was done in a system developed in the event lab by Ramon Oliva and others. So this is a platform where around 12 people can get together. And then what we did was to get together with some of the patients, with some of the developers, the researchers, and clinicians, and so on, and have a systematic acquisition of investigation of how was their experience. And I think this is quite, it's important, the fact that these people without a specific technological training, they can get instructions to do this from their homes, to be in a shared virtual environment, and to have meetings. And we have done a very detailed analysis of this. Well, I don't think I will show the videos now. I won't go into the detailed analysis because, as you can see here, there are many different. But generally, I can say there was very positive. The experience was very well valued. And also they have a physical meeting afterwards. People reported how they had this sensation that they knew each other. They have been together before. It felt completely different from a video conference. They have their own personalized bodies, their voices, their lip sync, their body movements. So they recognize each other. And they found it also because some of these people had low back pain, and they don't feel very much like socializing. They are isolated. They don't want to go out. And this opportunity of socializing and sharing with other people that go through the same thing, this sensation, it was very positively valued. So there were also many glitches, and they are quite funny, but I will skip it for the sake of time. And we have, as you can see here, all kinds of feedback. So we published one first paper on this, but we are going to have a much more detailed one. And if you have any questions, you can ask. Still I have a bit. So I want to mention now the metaverse to reduce gender discrimination. That was actually mentioned yesterday by Katja Siebrek from the Meta II project. So we want to use the metaverse for the good, and this is the topic of this conference. But as we have heard also, there are already sexual assault, sexual harassment, and actually last night I saw a couple of articles from the same day, misogyny in the metaverse, talking about Meta. So this is really a topic to take into account, a whole new world of sexism. So this is a problem, whether there is this harassment in the metaverse. And we have this project, Meta 2, that investigates these gender-based inappropriate social interactions in the metaverse, so what can be done about it. So we are doing different strategies with the other partners that Katja presented to design tools to enhance the user safety and to try to have inclusive avatars and to do also retraining of behavior to prevent harassment. So there is, I won't go into this part, but there is a poster by Sánchez-Vives presenting these virtual environments to try to enhance empathy and decrease and see experience in first-person perspective how it feels to have these behaviors of sexist behaviors and so on, and therefore try to get people to change their attitude. So they go also through embodiment, and there are measures and so on to try to quantify how is their experience, and then see whether their behavior
Por cierto, he visto tu perfil en Instagram. Tu avatar parece realmente tan hermoso como tú en persona. Eres una mujer joven. ¿Crees que tu aspecto ha contribuido a tu éxito?
Okay, so probably some of you already want to kill this guy. So that's a bit the idea, to try to make people feel in first-person perspective how it is this sexist behavior, and therefore induce a change in responses when you, not to harass, but also try to intervene if you see this as an observer. And there is this poster here. Also, Bernhard Spanlang presented how this can be done at the corporate level to try to train people in big corporations to reduce this kind of attitudes. And finally, in 5 minutes, I would like to present some work that started many years ago, actually in 2010, to reduce metaverse to reduce gender violence. I think it's a success case from going from research all the way to the real world. So we wanted to use this change in embodiment and change in perspective, actually taking the perspective of the victim to deal with a problem, which is the domestic violence, which, as you all know, is quite prevalent. And basically, the idea was to have embodiment to have the abusers taking the perspective of the victim and try to use different strategies to reduce this violent behavior that can have, as you can imagine, very bad consequences.
Arriba.
And then these studies, well, this is, you can get an idea of the type of environments where there is a situation of, this was just one of the environments. Now there is a whole collection of them that are being used in prisons. So I just told you the end of the story. This is being used now in different prisons without our intervention. But it's based on the scientific studies that we carried out during several years. So basically, what we did was to put first men without a history of violence, and later men that had a history of violence, or eventually that they were in prisons, through these environments where they could experience the situation of being verbally attacked or physically threatened by their partner, and they could experience this from a first-person perspective with this invasion of the peripersonal space and so on. We did different measures of subjective responses with different questionnaires, implicit association test, emotion recognition test, quantitative analysis of the interviews, physiological measures like heart rate, brain responses. Bea de Gelder presented yesterday some of these brain responses with this kind of environment, galvanic skin response, and then different behavioral measures. So there was a quite thorough investigation of what happens when you put, for example, men in this position of women in first-person perspective versus third-person perspective. And one thing that we have consistently observed is that there is, going through this experience has an impact on emotion recognition. So This is well known that people with aggressive behavior consistently, especially in prisons and so on, with serious violent behavior, they usually have a deficit in emotion recognition. And in all our studies, when we have especially aggressors in the perspective of the victim, there is a change in emotion recognition in the sense of an improvement in emotion recognition, which is something very tightly linked with empathy. So we found that, that there was this impact by going through these environments. And yeah, we could measure the changes in emotion recognition. For example, embodiment in the virtual female victim improved the offender's ability to recognize fear in female faces. So this is one of these effects in emotion recognition. So yeah, there was some measure. This Beatriz de Gelder presented it yesterday. One can see how it has an effect in the default mode network in the brain, and we did this also from the perspective of a child and so on. I won't go into details, unfortunately I will skip the movies. We have published different papers about this, but as I said, this has lasted, it started 15 years ago, a long time. We did first the studies in control men, this in aggressors doing voluntary rehabilitation. Then we started a collaboration with the Justice Department doing rehabilitation outside prisons, then studies in prisons, and then it was eventually integrated as a rehabilitation tool in the prisons themselves, and this is there has been now thousands of users, and yeah, it's being used at the moment in 5 prisons and in alternative sentences. This is actually inside the prison. This is one of our collaborators, a psychotherapist in the prison, and this is, well, there is a whole video of them. They all gave permission to be in this video, and this is actually a video where they discuss their experience and how did they feel being the victim, and how this can have an impact in their future behavior. As I said, it's very important that this is actually integrated in the rehabilitation. So it's not a unique, isolated intervention, but it's integrated, and then they can work with the therapist about the different experiences that they had, and so on. So it's integrated in the rehabilitation programs, but we continue this collaboration with them, and they keep asking for new contents and so on. So yeah, we have, since I'm in the law school, again, we have had some publications in Justice and Trends, and there is actually in the justice systems different possible uses of the metaverse, training professionals, rehabilitation of different types of violence, rehabilitation of substance abuse, evaluation of efficacy of the interventions. There is also someone studying reducing anxiety for defendants in trials. So there are many uses in the justice area. And I want to thank funding and collaborators, and thank you for your attention.
Thank you. We have time for some questions. No questions? Still digesting? Yes.
Thanks very much. This is just a fantastic body of work. So perhaps just to underline to the audience, the range and the amount of work here is really impressive. So thank you very much. And it shows, I think, something which is consistent with this idea of a metaverse for good. So my question is about the pain research. Lots of factors affect pain, and it's really difficult in pain studies and pain rehabilitation studies to know what is the correct control condition, because there are placebo effects, there are what is called therapeutic alliance effects, and lots of tricky sort of psychosocial things. And I just wonder, what is your experience of the correct control conditions? And do you think that these kinds of virtual therapies and metaverse therapies can improve the quality of the experiments so that they have better control conditions and better ways of testing what is the actual effect of the intervention. Thank you.
Yeah, that's very important. And there is two aspects to it. One is that if you want to do a scientific study and know exactly what works, and this is what we try to do, we try to change the color of the body and change the transparency and change the size and change the movement, and you want to understand it this way. Then when you work with patients, at the end what you want is to be effective and reduce their pain. And then this is why in the last study we did what we were avoiding before, which was just to put everything together, and it works. It works quite well, and we've seen that it's successful to reduce the fear of movement, and this has an impact on real life and decrease pain. But of course, by putting everything together, then we don't know so well what is exactly the most efficient. Is because yes, they were in virtual reality, or because they did Tai Chi, and then there is the problem also of the controls. And actually, our controls, we see that their pain reduces just if we put them in virtual reality every day, devoting 20 minutes to watch YouTube. And already this decreases pain per se. And we know this, and actually it's positive to know that there is something that first you relax, you disconnect from the real world, you are fully immersed in another reality, and this decreases the pain per se. So of course the important thing is how much you add up by doing very specific interventions. So it's very difficult to have the proper control because because you can just put something in a screen, or you can just give them other contents or very similar contents. I think the perfect control is impossible. And you need to work with these constraints, basically. But in this last study, we just pour everything, and it is positive, I mean, I can say. Yeah.
Thank you. Any other?
Okay, so thank you, Mavi. It's a very fascinating presentation. So I really like you lots of research about release the pain in virtual reality. So I'm wondering if we want to use virtual reality to release pain, is that only a short-term effect, or maybe we can use that in the long-term effect in rehabilitation?
Yeah, I think, so first of all, people now can do it at home. They can have their head-mounted display. They are cheap enough. Actually, some of our patients, they finish after 3 or 4 weeks, and they wanted to keep doing it, and they ask us, if we buy the system, can you give us the software? And some of them are motivated enough to keep doing it. So this is a way to use it in long term, but also, as I said, in the case of low back pain, okay? In low back pain, there are we select patients that they don't have organic lesions like a disc or a very important organic problem. So, this type of pain, a lot of it comes also from the tension that prevents normal movement. So because they get more relaxed and they have less fear of movement, they said, once I saw my virtual body moving, then I kind of started moving more in the real world. So this movement in the virtual world had an impact on how they moved in the real world. So it's kind of an re-education of movement, and this is what can make it persist in the real world. This was always our problem, because we usually did pre-post interventions. We measure pain before, and then 20 minutes after, the pain decreased, but we said, how is it going to prolong in the future? So now we know that if you can change how people move and how they feel about the pain. Also in this intervention, for example, we had some information about pain. Sometimes some of the fear comes from not understanding well, what is happening. So you give them information, also pure information about why is there the chronic pain, how moving is not bad for you. And somehow also some of them value very much just getting information that maybe their doctor never had the time to give them. So altogether, seems to have a long-term impact. But also nowadays, people can use with these head-mounted displays at home. Yeah.
Thank you. We have time for one more question, if there is any. If not, I have a quick question. So I know you studied lots of adults, but have you studied any children? And if do you think it will work slightly differently for children just because their brain is more plastic?
We've never ever
Yeah.
worked with children because we thought it's difficult for the ethics and so on. So we never did anything with children. Yeah.
Okay, cool. Another round of applause for Mavi before the break.